Now, next problem is find the transfer function E out S for an electrical circuit. E out S divided by E and S for this. This is an amplifier. So we have an input circuit where there's a gain, amplifier gain is there, and we are boosting the output signal. That's all. This is the circuit given to you. So if we are required to find the transfer function for this one, what should be our analysis? Now you can see there is a input side. Just a second. Okay, sorry. Okay, there is an input side. You can see E in, E in of t in time domain. Then there's a current in input side. There's a loop second, and there's a current in the output side also. And we can see the current flowing is I2 of t. Capacitors are on both sides, and we are getting the input signal as well as the output signal. Now we need to find the transfer function. So we write the KVL equation. We'll start writing the KVL equation. So solution of this numerical is applying KVL to loop 1. I will apply the KVL. I will be writing directly this is minus and this should be equal to whole of this. So I think you are familiar with these equations now. E in of t will be equal to, first will be the capacitor 1 by C 1, and the current here will be I dt, that will be I1 of t dt. Then we will have a resistor and current flowing through this is I1. So that is R1 I1 of t. Sorry, this is R1 itself. So let's write this equation number 1. And second equation we'll be writing very clearly. The voltage across this resistor is V1. That V1 should be equal to, V1 is equal to R1 into what's the current flowing through this is I1 of t. That's the second equation. And third equation is because output will be 8 times, output voltage will be 8 times more than the input voltage. So because this is an amplifier gain, so here we will have V2 is equal to time domain, sorry. Here also you put it in a time domain, V1 of t. V2 of t will be equal to 8 times V1 of t. So these equations are given for us. Okay. Now, right, this is for the loop 1 we are getting the equations. So applying KVL to the loop 2 now. Loop 2 now. You can see in loop 2, this V2 voltage is minus, we can take it here, then this V2 voltage will be sum of these voltage, that is uh, voltage across this capacitor C2 and the resistor R2, we will call it. It's not R2 here written, but it should be R2. Okay. So I will write down this equation directly. V2 of t should be equal to 1 by C2 I2 of t dt plus I2 of t, that's the voltage across the resistor 2. So let us call it equation number 4. And then we have, can very clearly see that output voltage E out will be current flowing through this multiplied by the resistor R2. So E out of t will be R2 I2 of t. That should be equation number 5. Okay, now taking the Laplace transform of all the equations from 1 to 5. from equation 1 to 5. So first we will have in of s, that will be c1, 1 by c1 is there, that will be 1 by c1 of s, and I1 of s, that you know what is the Laplace transform of capacitor. I1 of s plus I1 of s. So E in of s can be written as, so we'll take the I1 of s common, and we can write 1 plus R1 C1s divided by C1s, and we will multiply this by I1 of s. That's the equation 1 dash, we call it this equation. So similarly, what is our second equation? We can take the Laplace transform of second equation V1, and this is V2. Okay. So taking the Laplace equation V1 of s is equal to R1 I1 of s. So let's call it 2 dash. Dashes are the Laplace transformers. Here, out of this, for the sake of simplicity, we can consider I1 of s will be equal to V1 of s divided by R1. Fine. Okay. So next is V2 of s will be 8 times of V1 of s. Okay, nobody's there. That will be third dash. Laplace transforms are dashes. I'm again repeating. Okay. From V2, we can get what are we? V2 of s is equal to, can have a look here. Can change this 1 by C2 of s. Okay, then we have I2 of s plus R2 I2 of s. Let's call this equation. Just a second. This is same R2 I2 of s. Okay, I will add a page here. Okay, now here we have reached. So out of this we can get the value. So V2 of s will be equal to, you can see here, V2 of s. We can combine this and we can take Y2 of s common. So 1 R2 C2 of s divided by C2 of s. Just a bit of simplification is done here. So that is 1 plus R2 C2 of s divided by C2 of s, and we will call this will be multiplied by I2 of s, and we'll call it 4 dash. Okay. Then we have E out finally. That will be the voltage across the resistor 2. Current is I2, that we already know. E out of S will be R2 into I2 of S. So that will be your 5 dash. Out of this, we can get the value of the current also, because we will require these values of the currents. Out S divided by R2. Okay. Now, substituting the I dash value, we can call it, just for the sake of name, V double dash. Okay. We can see we need to get E naught out by E naught out by E1 of. Now, step by step, we'll proceed. So now what we'll do, I will substitute the value of I1 of S. Where is I1 of S? I1 of S is here. So you can look here. I1 of S is there. Yeah, here. I1 of s, I will substitute that in equation 1 dash. What is 1 dash? 1 dash is this one. So I'm substituting the value of I1 here. So this will be E in of s, this whole thing, I will write V1 of s divided by R1. So here substitute I1 of s in equation I dash. I'll try to get everything in terms of, my aim is to get everything in terms of E out and E in. Then easily I can get the values. So that means EI of n, rest will become same, that is 1 plus R1 C1 of S divided by, what was that, C1 of S, I think. Yeah, multiplied by, instead of this, I am going to write what? V1 of S divided by R. You can have look here, what I have done, exactly the same thing. This is V1 of S divided by R1. I have substituted it here only. Okay, why? Everything is in terms of current. I want to avoid this currents, and I don't want to get in terms of current. I want to get everything in terms of the circuit parameters. That is my aim. So let us call it equation number 6. Okay, next is, out of this I can also get V1 of S, because somewhere I will need to replace this one also. So that will E I n of S R1, then it will be C1 as, okay, denominator is multiplied there, divided by, we will have 1 plus, okay, this is another problem now. This is V1 we have got. So now similarly we will be substituting I2 of S in equation 4 dash. Again, objective is to get everything that should not contain the current values in terms of the circuit parameters. That's all my aim is. In terms of the circuit parameters, I'm again repeating it. So here V2 of S, you can see here, very simple equation, V2 of S. I will substitute this E naught of S divided by R2 here. So this will come out to be 1 plus R2 C2 of S divided by C1 of S multiplied by E naught of S divided by R2. So I'll call it equation number 7. Okay. Substituting equation 6 and 7 in equation 3. You can see here. Now I have in terms of E naught everything. Equation 3 is here. Okay, sorry. Equation 3 dash. Where is 3 dash? 3 dash is here. V1 value I have, V2 value I have. This V2 is equal to 8 V1 dash. So I'll substitute the, I have value of V1 and I have value of V2 in terms of E1 of S, E2, E naught of S. So substitute equations 6 and 7 in equation 3 dash. So what we are going to get, that equation is exactly, I'm writing again, V2 of S is 8 times V1 of S. Okay. So V2 of S is here. That is 1 plus R2 C2 of S divided by C1 of S. Oh, sorry, C2 of S. Why we are writing it? It's C2 of S here. Okay, C2 of S divided by, multiplied by, sorry, E naught of S divided by R2, which should be equal to 8. What's the value of V1 of S? Okay, this is multiplied by I'm sorry, 8 multiplied by C1 R1 of S E I in of S divided by 1 plus R1 C1 S. Okay, now we'll take this E out. What is our aim? Our aim is to find this E out divided by E n of S. So we are taking this here and we will take all the things on the other side. So 8 R1 C1S, that's the one value. And from here, what will come? R2 C2S, that's the another value. And what should be in the denominator? Denominator, this has gone here, this will come out. So 1 plus R1 C1S multiplied by 1 plus R2 C2S. That's in the denominator. So if we further simplify this, E out of S divided by E in of S will be equal to 8 R1 R2 C1 C2, sorry, this is 2 S square divided by so that's all what we required. So this will box and that too will box it with red. This is what was required. I think this is a very simple question, just a manipulation of the equations, and every time you have to remember how to manipulate them. Manipulation is done. You have to avoid the currents. Everything should be in terms of what? In terms of circuit parameters. Let me draw the circuit. Actually, I should have drawn it earlier. Okay, now I will write the question here only. Okay, before going to this is for third will be for your homework. Okay, I will add a page here. So numerical number, this is 8. Sorry. So what we need to do, determine the transfer function of the given transformer coupled circuit. Determine transfer function of a given transformed coupled circuit. Okay, let me draw the circuit for you. Okay, here it will be. Sorry. Okay. Okay, here it is input voltage I, and the current flowing through this is I1 of t. Okay, here it is. I'll draw the circuit parameters after that. I2 of t. Here it is E2 of t. So here it is, first is resistor, then we have a capacitor, second, then we have a capacitor here, then we have an inductor here, then we have again capacitor, okay, then sorry, okay, then we have again resistor, okay, so this is R1. I think this should be R1. This is C1. This is L3. This is C2, R2. Here we have inductors again. Transformer coupled circuit. We have studied these circuits in the network. Okay, so dot conventions are here. This is the, okay. This is the mutual inductance. Okay, this is the question given to you, and you need to find the transfer function. Let us proceed for this type of problem. It's a very simple problem because you have studied already the networks. Those who know the basics, they will not face any sort of problems here also. It's an extension of those problems. Okay, so let's, the solution of this numerical is applying KVL to the both meshes. That is mesh 1 and okay. So not now what we are doing, we are applying KVL to both the meshes, and now start applying KVL. This voltage should be sum of the parameters, what will be the voltage across these parameters. So E1 of EI of t will be equal to what? R1 I1 of t plus 1 by C1 integral I1 of t dt plus, now voltage across, this is here inductor L1, this is L2. So voltage will be same, L1 di1 d of dt, that everybody knows. That is a self inductance. What will the mutual inductance? Mutual inductance will be because of the other effect, and sign will be negative because here the current is moving from dot to coil, here it is from coil to dot. So that is the opposite direction, and that you know already. I have taught you number of numericals in network. di2 of t dt. Okay, that is the equation number first. I think this is clear. Roll number 6, 9
Yes,
is
sir.
clear.
Yes, sir.
Those type of numericals we have taken. I don't think the people still don't understand this. So this is I2 of t. This here is I1 of t. Okay, I2 of t is what? Basically, it's the current flowing through this, and that's the voltage across the resistor 2. That will be multiplied by the resistor 2 and the current flowing through it. That is I2 of t. Let's call it equation number second. Now considering the second loop. Now in case of second loop, what will happen? Current is our this all parameters, and there is no voltage because voltage we have already taken across this. There is no voltage directly, so we can write this. Voltage source is 0. There is no voltage source, so R2 I2 of t plus. Now we'll move to the capacitor I2 of t dt. Then we'll move to the inductor. Inductor, it will be same. L3 d, what's the current flowing through? D I2 of t dt. Inductor L2 will be also the same. L3 L2 d, sorry, d I2 of t by dt. The leftover is only the mutual inductance, since again the currents, one is going from coil to dot, another is going from dot to coil. So in this case, what will happen? It will be negative, and negative will be m di1 by dt in this case. Let's call it equation number third. So these are the three equations you require for determining the transfer function. You require these three equations. These are very important equations and very simple equations. We have done lots of numericals in network analysis on the basis of these. So taking the Laplace transform of equation 1, 2, and 3. Sorry, we get. Okay, fine. So let's take the Laplace transform of these equations. E1 of s, that will be, it is 1, it's not I. So that will be R1 I1 of s. Very simple Laplace transform. You can take 1 by C1 of s, that is I1 of s, plus Ls I1 of s plus minus, sorry, M s I2 of s. Let us call it equation number 4, or 1 dash, whatever you want to call. Second, very simple, E2 of s will be equal to R2 I2 of s. That will be fifth equation. Okay, last equation, 0 should be equal to R2 I2 of s plus 1 by C2 of s I2 of s plus L3 s I2 of s plus L2 s. I think we have written wrong here. Oh yeah, this is fine. S, because this is the inductance only. This is not a mutual. L2, what's that? R2 plus, fine, L3s and L2s, minus will be only MS I1 of s. That's fine. So let's call it equation number 6. So we have got the equations in KVL, and then we have transformed into transform domain. We have converted those equations. Now what's our aim? Our aim is to find what? Transfer function. Now transfer function in terms of what we need to find. Simply transfer function will be in terms of the voltage, again E2 of s divided by E1 of s. That's what we will be trying to find. Now from the last equation, we can write from equation 6, what we can write. we can take this ms on the one side, ms I1 of s, because again aim is to eliminate the currents. See, this is the beauty of these questions. Everything has to be represented in terms of the circuit elements. That's same, whether it's active, whether passive. But uh, you have to avoid the currents. Okay, so transfer function in terms of the voltage will be, we have to isolate these currents here and then get the values of this. So we can take I2 of s common here, and we can simply write this as R2. I will take C2 of S as an LCM also. Then I will write down this R2 C2 of S plus, then I will write 1 plus, and L2 C2 S square. One by one I am writing L3 C2 S square divided by what? Divided by same C2 of S. Okay, nothing. I have taken LCM C2 of S. You can see I have multiplied the C2 of S everywhere. That's all. Simple mathematics. Okay. Now further, I can simplify this. Here it is I2 of S, I1 of S. So if I have to get everything in terms of I2, so I1 of S can be written as, because I want to avoid these currents in the calculations. So this will be R2 of C2 of S plus 1 plus L2 C2 of S square plus L3 C2 of S square. Then this will be divided by, will be multiplied by this. So M C2 M, that will be C2 and S square. Sorry. M C2 and S square, it will be here. And this everything is multiplied by I2 of S. Now let's call it equation number 7. I need this equation because I want to avoid, I don't want to have a calculation in terms of the currents. Let me add a page. Okay, from where? Substitute this equation number 7th in equation number 4th. Why? I will show you why. See, this is equation number 7th. I want to avoid this current, sorry. This is plus here, by mistake it says 1. Okay, I am going to substitute this equation number 7. No, this should be 7. Why I have written 8? This is equation number 7. Now substitute this equation number 7 in equation number 4. Why? Let's have a look. Laplace transform equation number 4. See, here everything is in terms of I1 and I2. So one of them I will try to avoid them. That means I will get everything in terms of what? I will get everything in terms of I1. That is in terms of I2. I'll substitute the value of I1 here. You can see here, common I can take I1 here. Then this I1 will be in terms of what? I2. So everything will be in terms of I2. So let's equation 7th in 4th. Okay, let's move ahead now. Now E1 of S can write will be equal to, you can see here, instead of, in place of I1, what we have to substitute this complete value. That's all. So I will write, first I will try to solve this equation. I1 of S R1, sorry, yes, R1 C1 of S plus 1 plus C1 L1 S square divided by C1 of S minus is SM I2 of S. This is the equation we are getting here. You can have a look. I have got C1 of S common, R1 C1 of S, okay, then 1 plus L1 C1 of C1 S square, that's what I have written, C1 S square, and then minus I have kept it here and I have multiplied it by the denominator, that will be M C1 S square. That's what I am written. Okay, you can keep it like this, no problem. We don't have to, even you can multiply, even you don't need to multiply, that's fine. So E1 of S will be, now what we'll try to do, we try to substitute the value of I1 of S. This is the value we are going to substitute now. So I have this value, I write it down here. So that value is, I1 value will be R2 C2 of S plus C2 of S square. We can, for C2 of S square, we can take common here. C2, L2 and L3, both values are same. So that's why I'm taking common. L2 plus L3, and that will be plus 1. And that will be divided by S square. Sorry. S square C2M. Okay. Then this value is complete for I1. Now let's have the value of the same thing. This is R1 C1 S plus 1 C1 L1 S square divided by, what is that divided by? Divided by C1 of S. Same, we are not doing anything to this value. Minus, we are keeping this value also same, I2 of S, because now everything is in terms of I2. You can very clearly see. Okay, this is multiplied by I2 of S here, sorry. You can see this is multiplied by I2 of S. Why I2 of S? I2 of S is coming from here. Here, yeah, this is multiplied by I2 of S. Okay, fine. Then we can further write E1 of S can be further written as, so what we will try to do, we'll try to multiply these two quantities. Okay, so I2 of S I will get common. I will try to multiply this. Okay, I2 of S I'm getting common in both the cases, and I'll try to make an LCM here. You can see. So first term will be R2C2 S, then plus C2 S square. Okay, C2 S square L2 L3 plus 1. Okay, that will be multiplied by this term, R1 C1 S plus 1 plus this is C1 L1 S square. Okay, so we'll close this bracket, and this whole will be minus. Now what's the LCM here? LCM here is LCM here will be multiplication of 2 C1 C2 S cube and M. So here we have already, in this case we have nothing, we have to multiply each and everything. C1 C2 M square S. C1, sorry, C1 C2 M square. One of the S will get cancelled, so it will be m square s. Okay, we can keep it like this for this step. मुझे लगता है थोड़ा लंबा हो जाएगा आपके लिए. I could have done it here only, but मुझे लगता है आधे स्टूडेंट्स को शायद समझ ना आए. C1 C2. Okay, fine. इसको मैं यही रहने देता हूँ फिलहाल. ठीक है, तो ये एलसीएम जो मेरे पास है, दैट इज द सेम थिंग. क्या एलसीएम है ये? C1, सॉरी, दैट इज C1 C2 m s क्यूब. इसको मैं ऐसे रहने देता हूँ, SM. ठीक है, इसमें I2 ही कॉमन लिया हमने खाली. इस टर्म को मैंने कुछ छेड़ा नहीं है अभी तक. ओके, नाउ इन दिस स्टेप आई विल डू, बिकॉज एक में थोड़ा ज्यादा हो जाएगा आपके लिए. E1 of s is equal to I2 of s. ठीक है, now this term we have got, we don't need to multiply this. ठीक है, we don't need to multiply this, so we just want to solve this first step. मल्टीप्लाई करने की कोई जरूरत नहीं है, बिकॉज दिस इज फाइन फॉर द आंसर. C2 s square L2 L3 plus 1, that is first term is over. Second, R1 C1 s plus 1 C1 L1 s square, second term is also over. Now we'll include the third term. That will be C1 C2 m square s4. M square you can very clearly see. Everything I have multiplied. So that will come out now complete, and that will be the denominator now. Denominator will be C1 C2 m s cube. So up to here there is no problem. Now I need to avoid this I2. How I can get this I2? I have one equation. Equation second I have. So substitute I2 of s. You can see equation number second here. I don't want to answer in terms of the currents. I2 can be E2 of s by R2. So I can substitute this. Substitute I2 of s equal to E2 of s by R2. Okay, in above. So now we substitute this, then it will become E2 of s. So इसको मैं यहाँ ले आता हूँ, E1 को यहाँ ले आता हूँ, and that is final answer I am going to write. So that is, this will be denominator s cube R2 C1 C2 m, and that will be divided by this whole term what we have, s R2 C2s plus C2s square multiplied by L2 L3. I'm not changing anything here. No need to multiply. Multiply करने की कोई जरूरत नहीं है. So conventional exam, and you need to just write the answer. So that will be R1 C1s plus C1 L1 s square, and that together, multiplication of these two is subtracted from this term, C1 C2 m square s4. Fine. Just a second. Okay. Okay, that is that answer we need to box, and that's what we require. So we can box this answer again. This is the answer for us. Okay, is it okay? हाँ जी, roll number 6, Tanzib.
Yes, sir, please.
Okay, so these were the quite one question. This is for your homework. Okay, so you have to do it yourself. Find the transfer function of this, and tomorrow you need to submit it. ठीक है, ये क्वेश्चन है, बड़ा आसान है. यू नीड टू जस्ट सॉल्व दिस. बाकी तो वही है जो मैंने पहले किया था. ये पैरेलल कॉम्बिनेशन है, इसको आप लैप्लास ट्रांसफॉर्म में सॉल्व करो. ये है s, ये है 1/s. इसको आप impedances को 1/s and 1/s को parallel में ले लीजिए, then you can find it easily. So this is for your homework. Okay, that's all for today. So this is transfer function is also finished. Next, we'll move to the mathematical modeling techniques of control system. That means there's a one portion block diagram technique reduction, and second is signal flow graphs. Inshallah, next time we'll be doing that. Of Tanzib, you can send the log.